Now for a study in a whole different realm of science, quantum physics. A local research group at the University of Maryland has made a breakthrough in teleportation. In a remarkable announcement, Japanese scientists claim to have unlocked a secret that once seemed reserved for science fiction: teleportation. They described a scenario in which one could wake up at home in New York, take a single step into a teleport device and find themselves sunbathing on a beach in the molds. No airplanes, no traffic jams, no long waits at the airport. Just one move, and you are anywhere on Earth. They pointed out how much money this would save on plane tickets. Imagine having breakfast at home and then lunch in Paris. The Japanese team working at Kyoto University in Hiroshima University reported that they have fully solved the teleportation secret. Well, at least for 3 particles of light, photons. These photons are much smaller than atoms. They say that their information was transmitted instantly, as if distance did not exist, and thus faster than the speed of light. Faster than anything known before. Even more extraordinary, they claim to have done what scientists had been trying for 25 years. They say they found a way not just to teleport pairs of particles, which had been done before, but to work with larger groups, and that they believe changes everything. Because if you can teleport 3 particles at once, then you might scale to 30, 300, or 3 million, which in turn means that teleporting entire objects might only be a matter of time. The story begins back in 1935. That was when Albert Einstein declared the idea impossible. He did not believe that particles could instantly affect each other at a distance. He called it spooky action at a distance. He believed his theory of relativity forbade information traveling faster than light. But his colleagues Boris Podolsky and Nathan Rosen developed a clever thought experiment, the EPR paradox, to challenge Einstein's view. Einstein refused to accept the possibility until his death. Years passed. In 1964, John Bell devised a test, Bell's theorem, to decide whether Einstein or his opponents were correct. In the 1980s, scientists finally conducted experiments. The results stunned everyone. The great Einstein was wrong. 2 particles really can be connected by an invisible link. If one changes, the other feels it instantly, no matter if they are centimeters apart or light years apart. Then the 1990s changed everything. Scientists realized this strange connection might be harnessed. If particles feel each other instantly, then maybe information could be sent faster than anything in the world. Not by moving the particle itself, but by copying its state elsewhere. They called this quantum teleportation. In 1997, the first real teleportation was achieved. A team led by Anton Zeilinger teleported the quantum state of a photon a few centimeters in the lab. It was a tiny step but a real breakthrough. The whole world talked about it. By 2002, scientists had teleported not just one particle but an entire laser beam, hence not a single drop but a stream of light. In 2006, something even more wondrous happened. A laser beam state was teleported into a cloud of atoms and then turned back into light again. Like magic, light became matter and then matter became light. In 2012, a particle was teleported across a city over several km. Distance was becoming less of a barrier. In 2016, China launched the satellite MISSES, the first space teleportation laboratory in history. In 2020, the Chinese team teleported particles from space down to Earth over hundreds of kilometers through the void. Space was no longer a limit for teleportation. But those were only early steps. In February 2025, scientists at the University of Oxford in Britain reportedly made a real breakthrough. They linked to quantum computers through teleportation over a distance of 2 meters. Quantum computers are special machines that work by quantum laws. They are millions of times more powerful than ordinary computers, but also very fragile. The British team learned how to connect them via teleportation like invisible wires. Not just particles but whole computing operations were transmitted instantly. The world thought, that's it, the British are first. But Japan had a surprise. In September 2025, the Japanese team did what had seemed impossible for 25 years. They learned to teleport not just one particle, but a group of several particles at once. The British had shown that teleportation works between computers. The Japanese found the key to scaling, how to move from single particles to groups, and that means to complex objects. Until now, all teleportation experiments were like a duet, 2 partners dancing. The British showed a practical step connecting quantum computers with teleportation without wires. But Japan went further. They made an entire group of particles dance. It was no longer a duet but an ensemble. For science, it is like transitioning from table tennis to football, or from connecting to computers with a cable to creating the worldwide internet. Why is this so important? Because working with groups of particles opens the path to scaling. If you learn how to control groups of 3, 10s, and hundreds, then you can teleport not just bits of information, but whole blocks, complex systems. Today, scientists teleport light particles, molecules. The day after tomorrow, whole objects. For 25 years, scientists believed it was possible. but they could not do it. Now, the Japanese have built a device able to catch what had escaped researchers for decades. But all these discoveries remain theoretical steps. Real teleportation of macroscopic objects requires technologies still under construction by the giants. For example, Google released the Willow chip with 105 CQITS quantum bits, the building blocks of a quantum computer. That chip can finish calculations in 5 minutes that a classical supercomputer would take longer than the age of the universe. Science Daily Plus to Kyoto University Plus 2. IBM promises that by 2029 it will create the Sling quantum computer with 200 logical qubits able to perform 100 million operations. Microsoft is developing topological qubits called Majorana 1, which can scale to 1 million qubits on a single chip. And in April 2025, University of Illinois researchers achieved teleportation accuracy of 94%, almost perfect transfer of quantum information. This means teleportation is becoming not just an experiment but a reliable technology. Even now, quantum computers are starting to solve real tasks. In March 2025, the company IonQ used a 36-qubit computer to simulate a medical device, a blood pump. The result, the quantum computer was 12% faster than a classical This was the first time a quantum machine beat a normal computer in a real engineering task. The quantum industry is growing fast. In 2024, companies earned $750 million. In 2025, the number is expected to exceed 1 billion. The United Nations declared 2025 the International Year of Quantum Science. The world is preparing for a quantum revolution. And the more powerful quantum computers become, the more complex objects scientists will be able to teleport. Every new qubit said, every improvement in stability and accuracy is a step toward teleporting not only particles of light, but also molecules, cells, and later objects. And what comes next? In the next 5 years, scientists expect to teleport simple molecules over hundreds of kilometers. Imagine this. A part in your computer breaks. It will be replaced instantly without opening the case. Are you sick? Drugs will be teleported directly into your body. A doctor in London teleports a rare drug to a patient in a remote village in Africa in seconds. The problems of delivering rare medicines to faraway places disappear. But this is only the beginning. Imagine a world without warehouses. A factory in China produces a part and it instantly appears in a factory in Germany. Oil from Saudi Arabia is teleported directly to Indian refineries. Gold from African mines appears in Swiss banks instantly. No tankers, no trucks, no trains. The space program will change forever. Why spend millions launching a rocket with cargo if building materials can be teleported directly to Mars? Astronauts receive fresh food, oxygen, and water instantly from Earth. In 10-20 years, teleportation of complex molecules, maybe even cells across continents, will become possible. Doctors teleport healthy cells into a cancer patient. Ready-built space modules and scientific equipment go to space without rockets. Farmers send elite seeds to any point on the planet instantly. Archaeologists teleport valuable finds from dangerous zones into safe museums. In 20-50 years, teleportation of small objects, maybe even simple organisms. At the same time, a global instant transfer network becomes available to everyone. Teleports appear in every home like Wi-Fi routers today. Forget about delivery. Your order arrives at your house in seconds. You order an iPhone from the Apple Store and it materializes on your table. You want sushi from the best restaurant in Tokyo and it appears in your kitchen hot and fresh. You need a rare flower for a bouquet. It teleports from some corner of the world. Pets travel to the vet instantly. Plants from exotic countries appear in your garden in seconds. Ordinary people access technology that changes every family's life. Teleportation stops being the privilege of corporations or governments, and it becomes everyday. Emergency services have changed completely. Firefighters teleport water directly into the heart of a blaze. Rescuers deliver oxygen under rubble instantly. Police teleport evidence from a crime scene directly into the lab. The main question: what about people? Here, the problems are huge. A person is made of trillions of particles. A model of human teleportation would work like this. Every particle in the body is measured in one place. The information is sent to another place. There an exact copy appears and the original body is destroyed. Visually, this is teleportation. You vanish in one place. A copy appears in another. But the moment of destruction is terrifying. Memories, thinking, feelings, are they all inside the particles? And what about the soul? The copy may appear, but will it be the real person? Where is the guarantee that some part will not be lost? In 30 years, we went from teleporting centime to cosmic distances, from one particle to large groups of particles. The Japanese and British teams this year showed 2 key puzzle pieces, then molecules, then objects, maybe even people. The only question remains, who will dare to be the first human teleported, knowing the original might vanish forever? Asterisk, asterisk, thank you so much for watching all the way to the end. If you enjoyed this deep dive, please smash that like button, share your thoughts in the comments below, and don't forget to subscribe and turn on notifications so you'll never miss a future update. We've got a lot more exciting tech stories coming your way. Until next time, stay curious, stay inspired, and we'll see you in the next video. Goodbye.